to this afternoon's presentation. I am Shaun Scholer from the Indiana Geographic Information Office, and I help manage our organization's imagery and elevation program. So it's been a long established process that we do collecting imagery and elevation data for the state of Indiana, and I'm pleased to pleasure to work with Kate and Jinha. So I'll go ahead and let them introduce themselves as well.
Hi, my name is Dr. Katie Chapman. I work at Indiana University, based in Bloomington, and I am the manager of the Indiana Spatial Data Portal as well as the Esri admin for IU.
Hi, my name is Jinha Jung. I'm a faculty member at Law School of Civil Engineering at Purdue University.
Thank you. All right. Well, let's go ahead and get started with a few slides here. I'm going to introduce just the program. Many of you might have already heard about and seen some of these slides, but I've also tried to refresh them. So we'll go through a few of these. But first, I'd like to just introduce our team here at the Indiana Geographic Information Office, the IGIO. And we have Marianne Cardwell as the officer in charge of both the enterprise and the programs and outreach. And on the enterprise side, it's they help manage the infrastructure. So helping with our portal, all the software, and all the licensing for our state agencies. And then on the right side, on the programs and outreach, that's where Steve and then I fit in, helping with the imagery and elevation. We also have the other programs and the staff supporting that. So let's talk a bit about a couple of the other big programs. And the first one is the Indiana Map, and that's where hopefully everyone is going to retrieve authoritative content from our sister agencies across the state, and also agencies such as Indiana Geologic Water Surveys. So a lot of maps, over 450. We also are, like I said, collaborating. We're no longer kind of sneaker netting those files around like we did in the late 1990s and early 2000s. This is using the Esri Hub technology. We're able to develop and establish direct links with these organizations and be trust that as soon as the information is updated within the organization, it's collaborated out to the Indiana Map. And lastly is the free access to ArcGIS Online account. So if you're a small organization or just an individual user and you'd like to get started with ArcGIS Online, be sure to check out those community accounts that are available. And then kind of under that, there's a couple different programs. And the first is the data harvest. That's where we collect from local voluntarily. I want to emphasize voluntarily from local government. All 92 counties contribute their address, streets, parcels, administrative boundaries, and then we also receive a copy of the DLGF property tables and make all that available on the Indiana Map. So going back up to that overarching program, Indiana Map. And lastly, the last point I want to mention is that address lookup. So we take through the homogenization process of taking all 92 data sets and turning them into one. We also produce a geocode or address lookup that is publicly available. So if you're looking to gain access and to a free lookup, address lookup, please check that out. And all right, and then our other program, which is what we're here for, is imagery and elevation. So Indiana's had a long history of collecting imagery, all dating back all the way to 2005. Some of you may remember that. Our first collection, it was a single collection across the entire state. It actually ended up taking 2 years. There were some reflights required, and one of the first lessons learned was that an entire collection of for the state was more than we were able to take on. So from then on, we've always divvied up the state into 3 tiers. We have the center tier in green. We have the tier 2 in blue, and then off to the west side, tier 3. And this year, this program cycle, I should say, is a little unique in that we're collecting both imagery and LiDAR for this program cycle. And many of you probably remember last year what we were talking about collecting tier 1 with the imagery and LiDAR, and we had some trouble with the sensor that was being used, and as a result, we were able to collect imagery, although we were not able to collect LiDAR. So what Wolpert is providing is imagery only for tier 1 in 2025, and then in this spring, 2026 of this coming year, we'll be collecting imagery and LiDAR again here for the center tier, and then we'll just march forward through the subsequent tiers. So. But yeah, something to note is that our LiDAR collection, this will be our third collect. This is unique within the nation. Indiana is one of those. Well, I think the only state that has multiple collections, entire collections for their state. So, and so now let's just talk a little bit about the program and why we have an imagery program for the state. And these are a couple I think a few nice words that I've picked up over the years, but these all speak to we know our organizations need aerial photography, our organizations need LiDAR, and why do we need it statewide? And that's where these really speak to that. And the other thing that really hit me was when folks requested download the imagery from the previous cycle, all the users that submitted the survey said they need imagery for more than just their single county. So I thought that really spoke as well to the need for a statewide program. And so here, talking about some of the advantages of the program. So number one, it's authoritative. There's a lot of different sources for imagery that you can get. Many of them are free and easy to grab, right? Google imagery and various other imagery sources. But this is authoritative in that the resolution, the accuracy, when it was collected, and all of those are important when putting those into your business model. So here are the collective buying power. There's always the option for communities to purchase additional products, and the procurement and management, taking that lift off of local government and others that would have to be going out to RFP to manage their imagery or elevation collection. The quality control, quality assurance and control, that's also managed by the state. It's a really cool process, and I have a couple slides to that. But also the reliable schedule and the cost. So, all right. So here is the NDOT's aerial surveys team. They've been reviewing imagery products dating back to 2011. So as a partner to this program, and what they do is they go through and review the seam lines, the bridge decks, tonal balance, and just overall image quality. And they'll also be looking through the LiDAR DEM when we start receiving that next year. So they've been a long trusted source for verifying this information. And so here's the program timeline. The program it starts really way before January, but I couldn't roll that back any further. So, but the hardcore planning starts in January, and then in February, April we have the acquisition. We're in leaf off conditions, so so that's where the February April timeframe. March August we start that processing in stages, and then we also have the QA QC, and then the final products, and that's where we are in our calendar year right now, is in this final stage. And all the while, I want to emphasize that we're constantly working on building partnerships. So if your organization is interested in partnering for additional products, buy-ups, please contact me, and we can work with you and your organization to provide additional products for your organization. And now let's talk just a little bit about the specifications for what we can be expecting this program cycle. And last year when I was presenting presentations, well, I was talking about a 6-inch base product, and what we've been able to do in the meantime is find a partnership within state agencies to help fund the buy up to 3-inch. So no longer will communities have to find money to buy up to 3-inch. Everyone is going to get a 3-inch base product across the entire state. And again, it'll also be tiled 4-band imagery, so that red, green, blue, and near infrared. So don't want to overlook that near infrared band. It's always there behind the scenes, and very helpful for feature extraction, land use identification, popping out vegetation or water. It's an excellent source for that. And then the LiDAR-based specification will be quality level 1. That's a USGS term, but we've had the previous collections at QL3, at QL2, and now we're down to QL1. The QL1 carries a 10 vertical centimeter accuracy, so this will have the same vertical accuracy as our last collection, and then it'll also have a point density of 8 points per square meter. So that'll be very kind of increasing the resolution as we increase the point density. So. All right. One of the unique things that we're going to be focusing on in this collection is a co-collection. So you can see here, this is a image of Wolpert's aircraft that they're going to be using, and it has 2 ports on it, or 2 holes there on the bottom, one for the LiDAR sensor and one for the imaging sensor. So these are both fully developed, industry standard sensors that will be collecting both of these products for us. And what this means is that we won't have that time delay, which we oftentimes have in years past, where there's maybe a year's difference, right, between the collection, but we're actually able to collect both simultaneously. So what you see in the imagery, or what you see in the LiDAR DEM, is what you can expect to see in the imagery. And now let's talk just a little bit about some of the imagery on the side of imagery. So, first on the left side, I have a screenshot of Google Imagery, and my point I want to make through this transition is that we recognize what am I trying to say? What the design of the imagery. So, what is the imagery designed to support in Google Maps? And that is, it's predominantly used for wayfinding. It's not for feature extraction. It's typically a leaf-on condition, and that's where our program emphasizes leaf off, and then also that higher resolution. So, you can see here as we jump from 6-inch to 3-inch, the resolution increases as well, and also to mention that not only does the resolution increasing a magnitude of 4, the horizontal accuracy is also increasing. So here, just to talk, now that I've started talking about the accuracy, let's talk about a couple different types. So there's the relative accuracy. The relative accuracy is that it kind of defines that ability to consistently remeasure a width. So it's not an absolute accuracy. It's just measuring from a relative accuracy of one side of the road to the other, one side of the building to another. And that's what, there's a lot of different types of imagery sources out there that kind of carry that relative accuracy. And what I want to emphasize is the absolute accuracy, and that's where our program specializes, and others like ours, in other states, specialize in making sure that the absolute accuracy. So what we do to ensure that is to use GPS to collect survey control points, and then also we collect ground control points to verify and validate the accuracy and the placement of the imagery. So you can see then that when you place a pinpoint and you collect a coordinate, you can expect to see the same, the coordinate within a within a particular range. So for 3-inch imagery, you can expect to see the same coordinate within 6 inches. So that's really important to keep in mind. And then also just kind of lastly on speaking of accuracy, but perception matters, and that's where there's a lot of different image products again, and being able to when we start seeing things like this that where roads don't quite align, you begin to question the validity and of the imagery. So here, this is where Indiana is on our QA/QC. So currently, we're in the kind of that Hamilton County north of Indianapolis, getting up into Kokomo area. So these are the tiles that NDOT is going through and looking at and their status. And then here is the status of deliverables so far from Woolpert. So you can see here they've delivered imagery all the way up through Marion County now. So more to come. And then just lastly, wrapping up my slides will be, I want to talk about the imagery services. So these are all the different ways that folks can access this, and this is where I'm excited to have Katie and also Jinha talk about their organizations and what they've done to benefiting the public and Hoosiers to gain access to our products. So again, we host imagery services. These are open data and at no cost, and then we also have the ability to download. This is all the imagery we store in an Amazon open data container that is completely available for no cost for storage or for egress. And as you know, egress in the web storage is something to keep in mind. So, and then lastly, we have web map applications through the Indiana map that users can go about gaining access. So here just to talk about the partnerships, and that's again where this next portion of this presentation we're going to focus on. But local government is many. Over the years, we've had many local government partners in buying up to higher resolution or buying additional products. State agencies, we have NDOT, obviously, we have DNR with the Lake Michigan Coastal Program, IoT, and then we also have our federal agencies, the USGS, NRCS, and then higher education folks. Here is, this is an exciting map to talk about so one of the, we're partnering with the USGS on the elevation side. We've talked a lot about partners on the imagery side, but this is a big one for the elevation. And so this is where, Indiana isn't the lead on, we are the lead on our program, although we're collaborating and partnering with the USGS. So the final deliverables will be hosted in our AWS and will also be available on the Indiana map. And as you can see here on this map, the USGS is really proud to be wrapping up an entire continental United States collection of LiDAR. So, all right, with that, I'm going to jump into just a couple of my favorite links. So here on this top resource, and this will be available for you later as well, but we have the imagery and elevation resource pages. So on here, you can go through and read about the program, and you can see the additional resources you can buy up. You can learn about the different types of imagery and what it can be used for. You can also see the previous collections. So that's both for the imagery and elevation. And then for the imagery REST services, we have that down. Oops, I'm not sharing Let me move that over. Nobody said anything. Whoops. Sorry, guys. There we go. So here's the resource page that I was speaking of, and on this page you can see the layout of the tiers. So you have tier 1, tier 2, tier 3, and the history of our programs and such. So next, I'd like to emphasize is the REST services that we have. So we have dynamic imagery services, and we also have those cached imagery service. The dynamic imagery service is really beneficial because it's allowing the user to gain access to that raw pixel value. So if you're wanting to perform, to retrieve the elevation data, you can click here and scroll through and pull up the 2016-2020 digital elevation model. And within this, you're able to then select a pixel value and retrieve the actual elevation for anywhere in the state. Likewise with the imagery, we can flip back here, and all of these can be added to ArcGIS online maps. They can be added to ArcGIS Pro. They can be added to, as Jinha will demonstrate, in QGIS. So, and then here, the next I'd like to emphasize is our photo centers. And by clicking on here, you can see that we have the individual layers broken out. So we have 2024 by 6 inch, 2024 by 3 inch. But I'm going to go over here and choose Open in ArcGIS Online, and then we'll be able to see Open in Map Viewer. There we go. And is it going to give me too many? Nope, there we go. All right, so here, this is a really great way and useful way to determine when the imagery was collected for an area of interest. So you can see, and we've color-coded each of the months consistently. So February is always going to be blue, March is always going to be kind of that tan or yellowish color, and it allows you to see then when the imagery was collected. And predominantly, within an area, it's always going to be the same month. Although, over here on tier 3 of 2023, you can see that there were several flight lines that were had to be reflown, just portions of. So that's where this can be very beneficial if you're using this for permitting or verification purposes. But we carry the day, month, and year of each image. So, and we'll be having that again for 2025. So you will be adding that to this feature service. And let's see, let's go to my other option here is the tile footprints. And here again at the Open in ArcGIS Online, we also have again the individual years broken out. But let's go here to ArcGIS Online, and these can be added. These feature service can be added to ArcGIS Pro or to any other GIS desktop product. And let's see, there we go. Open in Map Viewer. All right, and then we can. I'm just going to zoom in. And you can see that we have the footprints for all of the years, all dating back all the way to 2005. And let's just go ahead and click on one of these tiles. And here's the image tile for 2024, and allows you to download the GeoTIFF. It allows you to download the ECW. Let's just go ahead and I'm going to be a glutton, but here we go. It's a 100 meg file, and it downloads pretty quickly. So the TIFFs, the Mr. SIDs and ECWs are much smaller, but you can see the performance is really good for the size of file we're trying to download. So, and if you scroll through the bottom here, you'll also see that you have the mosaics available, and you also have access to the metadata. So not wanting to overlook that. So with that, I am going to hand it over to Katie to talk about the Indiana Spatial Data Portal.
That's showing up all right, Shaun?
Yes.
All right, and for folks who joined a little bit after the introductions, my name is Dr. Katie Chapman. I work for Research Data Services, which is a team under Research Technologies, part of University Information and Technology Services at IU. I'm based in Bloomington. Part of my position is GIS data management, which includes managing the Indiana Spatial Data Portal, or the ISDP, as well as serving as the Esri admin for IU. And so today I'm going to talk a bit about the history of ISDP, its infrastructure, and how we structure the data and our workflows for processing data and ingesting it into the site for y'all to use. I think I muted notifications now, I hope. All right, so what is the ISDP? So if for folks who haven't used it before, the ISDP is a database of public domain geospatial data for Indiana. And so ISDP has actually been around a really long time. It was a use case developed for the Scholarly Data Archive, which is the tape archive at IU back in the late 1990s. So it's been around for almost 30 years now. RDS hasn't managed it that entire time. RDS took over in 2017, and we have done 2 major rebuilds for ISDP in that time, and the most recent one being in 2022. So what kind of data we have in ISDP? And so the sources for our data are primarily from the state imagery initiatives that have been conducted since 2005. So we have statewide data sets from 2005 through the most recent run through 2024, and we'll be adding the new data as it becomes available for the next few years as well. We do have some data from county and townships from local regional sets that were added to ISDP from a while ago, and so we do have additional, more local regional sets as well. We have some historical imagery in ISDP, but not a lot. It's a bit from Bloomington and Wayne County. These were data sets that were included in the early days of Scholarly Data Archive use case was first set up for ISDP. And if you don't know, we actually also have all of the Sanborn Fire and Insurance maps at IU, or the repository. And so in ISDP, we have all of the public domain Sanborn Fire and Insurance maps for Indiana available. And so every January, we add the new year that comes into public domain. So if you're trying to access those, we have them available as well. We have several versions of the USGS topographic maps in ISDP as well that you can access based on the different file formats, and those are all for Indiana as well. We have primarily orthoimagery in the ISDP. Probably like 95% of our data is orthoimagery or elevation data. We have a very small number of vector files, and so most of it is going to be tiled or mosaic imagery or elevation data. And so we do have all of the statewide and most of the regional data sets are tiled orthoimagery, some of which have mosaics. The file formats you primarily find in ISDP are GeoTIFF, ECW, and Mr. SID. For elevation data, we do have several of the LiDAR data sets for the entire state, as well as a few regional ones as well. We have some digital elevation models and digital surface models. We do have a smaller number of contour data sets. Those aren't included in all of them, but we do have some available for the state. In terms of who is using ISDP, we have a pretty wide user base, primarily from Indiana and the surrounding states. Illinois, Kentucky, Ohio are where the majority of our users come from, but we do get some from further away as well. We have a lot of users in state and local government agencies, INDOT, Department of Natural Resources, USGS, lots of county and city local governments. We also have a really wide group of commercial users who are ranging from utility companies, engineering firms, architecture firms, and landscaping companies, really anyone that needs orthoimagery data for their work, either on a small scale or a large scale. We do have a fair number of education users, and not just from IU. We have a really wide base from across the state, Purdue, Ball State, and lots of others. We also see a fair amount of downloads from education institutions outside of Indiana, Maryland, a few other places as well, because folks who are looking for different types of GIS data to process for classes. So I want to give you just a bit of an overview of ISDP's infrastructure, so you can see how it's all put together. And so the ISDP is actually the first instance of a service we developed in Research Data Services called the Scholarly Data Share Service, or SDS, which is one of the services that I manage. And so we developed this and starting in 21 with the goal of redesigning ISDP. And so SDS is designed to share very large data sets, either internally or externally to IU, using asynchronous delivery. And so that means that we don't have an immediate download for things. We have the infrastructure set up to, you make a request, and then that's processed, and then it's downloaded from our tape archive. The design principles for SDS were very much designed to be affordable. We wanted to be able to maintain these services long term. And make sure that the infrastructure was also sustainable in terms of support. The previous instance of ISDP had a lot of custom code that proved to be difficult to sustain over time. And so we were very much looking for things we'd be able to maintain for a long period of time. We also wanted it to be very scalable. We wanted this to work for small research data sets, but also very large ones like the ISDP, which has over 80 terabytes of data in it now. We also have an element of customization in the SDS service that isn't always available in some other repository options. A lot of research data repositories have a set metadata structure or have limits on what you can describe or how it's presented, and it's mixed in with a lot of other data sets. In SDS, we have separate websites which have customized metadata schemas to fit the data sets to be most useful for the users and for long-term access and metadata preservation for those data sets. We do have a couple of papers published about this service. We have links there at the bottom, and you'll be able to see those in the webinar as well, if anyone's interested in reading more about SDS. So, one of the most important aspects of the ISDP is where we're storing the data. And so this is the Scholarly Data Archive, or the SDA, which is the tape archive we have at IU, which has some beautiful artwork on the front. So this is the picture on the slide is of the actual archive. You can see at the end, those windows, you can actually see the tapes in there. And so with the tape archive, it's a physical retrieval. You submit a request, the system retrieves the tape and reads the file off of it. The SDA has a total storage capacity of 79 petabytes now, and they plan to keep expanding that over time. The SDA is the best choice for our long-term storage and access of the ISDP dataset because it is a distributed storage service, and so it's replicated across 2 physical locations. We have versions of this in Bloomington at the data center and in Indianapolis. So this is a disaster resilient environment with replicated data. If something happened to the Bloomington data center, the data would still be safe in Indianapolis and vice versa. And so this is secure archival storage for a lot of the research data at IU, including a very large-scale digitization initiative, Connect Here, within the past decade, as well as some of the Indiana State data as well is stored on the SDA, if that gives you a sense of how reliable we consider the SDA to be. And so it was the right choice for our data in terms of long-term preservation and access. It did also mean that when we were structuring the data for the ISDP, we needed to take optimizing the data sets for tape storage was an important consideration. And so on a tape archive, having, in the case of ISP, millions of tiny files, some like only a few kilobytes, some several megabytes, does not work well for a tape archive system because of that physical retrieval. So to be good stewards of this resource, we had to keep that in mind as we were doing our data structuring for the new ISDP in 2022. And so I'll talk a little bit about our data workflows now, looking at how we structure that data and how we arrived at the organizations for data that we did in this process. So our data workflow really prioritizes automated and scripted workflows. We wanted things to be consistent and repeatable across different data sets as much as possible. And so we have a series of scripts primarily in Python that generate data archive packages for us, which are then also paired with metadata about those data sets and then ingested into the front end, which is run in a platform called Omeka S to make the metadata searchable and to make data available to users, both the general public inside of you, anyone is able to access those. And I mentioned optimizing the data sets for the SDA. And so when we were looking at this, we tried to find a general organization for the data structure that made sense in terms of GIS data as well as for the size files we wanted for the SDA. And so obviously things like county level would have been much too large. There could be like hundreds of gigs per county of data depending on the data set, particularly the geotests. And so when we were organizing this, we arrived to the conclusion that the most consistent way to organize the data would be by USGS quadrangles, the 7.5 minute or 24K ones. There are 711 of those across the state of Indiana. And so all of our data for ISDP is processed to be packaged into datasets that correspond to each of those quadrangles. And that way we had datasets that primarily were small enough for users to manage, an average size of 2 to 5 gigs is the primary size of most of our datasets. So they are optimized for SDA, but also still usable by the users and user recognized GIS division for that grouping. And how do we do this? Okay, so I mentioned Python scripts. And so we get the data from the state. Most of you who've worked with the state data know it comes with a primary file that has one or more sidecar files with it that provide additional information. So the first step we do is we upload all of the data to our HPC, or high performance computing storage system, and process the data to just package all of those individual files together so that each primary image file is paired with its sidecar file so it doesn't get separated from those. Whenever possible, we try to use Globus, which is a secure and encrypted file transfer system for our data. It always confirms that all of the data is where it's going, and each of the data transfers can be carefully tracked. We process all of the data based on the coordinates made available from the state in their metadata files with those tile index files that we get as shape files with each data set. These are also available as metadata through ISDP as well. And so we have a couple of different Python notebooks that we've run in ArcGIS Pro that extract the coordinates from those shapefiles and generate the processing metadata that we need in order to get the X and Y min max coordinates for each of the tiles, so that then our next phase of processing can determine where each tile exists within the state and at which quadrangles it should be packaged for. And then this Python script packages the archives and does all of the naming for us, following a set standard for how we name each of the files to include information about the year, the imagery initiative, and the file type. We also have a Python qualities control script that we've developed over the past about 18 months that goes through and makes sure that all of the files that are in the original data set are included in at least one of the archives so that we don't lose any data in the process of doing this packaging. We then use Globus to move the files from our high performance computing storage, usually on Slate, to the SDA for long-term storage in the tape archive. I mentioned metadata being a really important part of this process. And so we came up with a basic metadata schema for ISDP that we could use in Omeka that would let people search by parameters such as county, quadrangle, file format type to make the data discoverable through the ISDP. The Python scripts generate that metadata for us. We then do a review of it and then ingest it into Omeka S, where it can be used in the user interface to search and browse data. And quality control workflows were a really important part of this that we've been continuously working on to make sure that they're as accurate as possible. Again, we want to always make sure that during this processing, all the files are included in the final packages so that everything is safe on the SDA over time. And so our Python script goes through, does an initial count comparison, do the number of files match, but then does go through and compares by file name. If for some reason a file isn't present in the data archives that from our script processing, then the quality control script generates a CSV file with a list of the file names that we're missing so that we can go back, determine what happened in that case, and make sure that everything gets reprocessed so we don't lose any data during this data curation process. We have also added a post-processing step after the data is processed. We've determined over time that the optimal size for user at download is definitely under 30 gigs. So we are going through and revising files that are over 30 gigs when they're processed as a quadrangle into quarter quads, which is another established GIS division. And so it's not something that we had to come up with, something that folks working in GIS will already be familiar with. And so in this case, it's the same script process for coordinate processing for quadrangles. Just here we use the coordinates for the x, y, min, max for quarter quads instead. They're still accessed in the same way in ISDP, except instead of having one download link for the datasets, you'll see 2 to 4, depending on where in a quadrangle the dataset lies, and then you can download each of those individually. Then, and with a note too, for consistency, we try to keep all of the data set processing at the quadrangle level for the existing data in ISDP. With the increasing size of file, the increasing file sizes that we're looking at as we move into higher resolution data processing and imaging, particularly with the next round being for the entire state at 3-inch resolution, then the file size, particularly for the GeoTIFFs, is just going to keep increasing. We have the Q1 LiDAR, and so for the newest round of imaging, we plan to process all of the data at quarter quad level for consistency, since we've seen at 3-inch resolution, if a quadrangle has full imaging for that, sometimes because there's imaging is done by county, it doesn't include a full quad, so it might be smaller, but some of the quads at 3-inch resolution can be 100 gig on their own. And so moving forward, we will be shifting to a quarter quad division for all of the higher resolution data sets for that consistency and to make sure we have as optimal a user download experience as possible. Wanted to look at a couple of quick statistics about ISDP, and then we'll move into a demo of the site. So right now we have 265 datasets in ISDP, and datasets in ISDP are collections based on the year, imaging initiative, and file format. So for example, one data set would be like 2024's in DNR imaging, and so one of the by file format. So if we have 3 different file formats for a data set, GeoTIFF, Mr. SID, and ECW, we would have 3 different data sets in ISDP that represent that imaging initiative. So all of those data sets include a total of over 35,000 individual data archives, which are the actual files stored on the SDA that are retrieved for users. Altogether, that's about 83 terabytes now. We're expecting by the time we process next year's imagery that'll be at about 100 terabytes and probably 120 to 30 by the time we get through the next round of imaging with the elevation data as well. In terms of our service stats, since we launched the new website in April of 2022, we've had over 2,500 unique users download data from the ISDP who have submitted a combined over 30,400 download requests for a total download volume of over 223 terabytes. So we're very excited for the amount of usage we have in ISDP, and we hope you folks keep using it and finding it to be useful. So using ISDP, moving into the demo phase of things, which never goes wrong, you can find the ISDP at gis.iu.edu, and we'll go there now. So when you first go to the ISDP, there is a login required, but it does not have to be an IU account. It can be either an IU or IU guest account. If you do not have an existing IU guest account, you just click the link here, fill out this form, verify your email, and then within 5 to 10 minutes, you'll be ready to go to access data within ISDP. When you do log in, you'll choose between either a university login for IU users or a guest login with your email. And so once you're logged in, you'll see the site itself. And so you'll have an opening page with a little bit of information about ISDP. We do have a detailed about section that describes the ISDP and how to access it, download data, acknowledging grant support if you're working with research data gotten from the ISDP because of the funding for the infrastructure that it uses. We also have a site walkthrough that gives you an overview of how to use the site as well. There are several different ways to find data within the ISDP. And so you can just browse the 250 odd data sets within the site. That's one option that you can go through, and there's collections here. And so each of those data sets, again, are grouped by year, the imagery initiative, so if the statewide ortho imagery work, and then file format is also included in the data set name. So GeoTIFF, ECW, any other feature that makes sure that we have a unique name for each data set. When you go in to view a collection of data in ISDP, you'll get some general metadata about the data set itself. But then you'll get a list of each of the quadrangle archives that are included in that collection. When you look at the actual items where you will do the download request, you'll see all the name information provides year, imagery initiative, and file type, and then the name of the quadrangle that it belongs to. You'll see two links. You can click to download the metadata for a particular archive, and then you also have click here to download the data set. You'll get an acknowledgement that it was submitted, and then it'll start doing that request for you. So when you click that link, it initiates a request through our middleware system, which was designed by one of my former colleagues, Huang-Chin Ruan. And after the request goes through the system, you will then get an email saying that your download is ready for, is available. The downloads are only available for 24 hours to keep our staging area where we keep those files we've retrieved from SDA available for other users. And so please make sure you download your request within 24 hours after it being processed. Each of the items in ISDP has metadata help search. So a quadrangle may fall across multiple counties, and so we have a list of all the counties included in that archive, the name of the quad itself, as well as the quad ID, the date, dataset type, units, primarily the data in ISDP is feet. I think the only ones in meters are some NAPE data that we have, and then the file format. If you are looking for more information about the imagery initiatives themselves and want to browse kind of by initiative, we have web pages that describe each of the major kind of divisions of data in ISDP. So we have the statewide imagery, statewide elevation, regional data sets for those we do have in ISDP. We have several years of the National Agricultural Imagery Program data sets as well. Then we have pages for the standard board maps and the topo maps from UGS. So if we look at the statewide imagery, we have links to each of the initiatives that we have data for in ISDP. If we go to the most recent, 21 to 24, all of the pages are set up this way: an overview of the initiative, and then links to each of the data set and collections that are available. So we have 2021 GeoTIFF, Mr. SID mosaics, those county mosaics, and ECW's files. And then we have them for each year for what data was available that year. At the bottom of the page, you'll find more detailed information, which ones are 3-inch or 6-inch resolution, as well as information for the files themselves, which is drawn from the metadata provided to us from the state, and the spatial reference information as well. And so we have that available for each of the major download initiatives. Elevation for regional data sets, it's grouped by the county or township it belongs to, and so you can browse by county, and then they're organized by year within that. And these were data sets that were contributed to the ISDP within the first couple of decades of it, I believe. And then we haven't been adding regional data regularly since then. We do have a few city and township data sets, as well as some state parks, as well as Camp Atterbury and Muscatatuck as well. So if you're looking for those data sets, you can browse them here. You can also do a search in the site, dataset search, or a full text word search in the search bar. And so if you do a search through the general site search, it'll do a full text search and bring you to the list of results. Here on the advanced search page under dataset search, you can specify the metadata fields that you want to search. So if I want to look for Marion County data, I can add additional metadata fields that comes from, let's see, the data set is LiDAR, and then I can search, and the results that come back, here we've got 41 results. We have added in a few new features for search results here, so now you can filter your search results by dataset type. So if you're already searching for LiDAR, that's less useful, but if you're just searching for a county, you can sort by that. And then you can sort by a file type as well. So if we just did a search for Monroe County within ISDP, it would return a list of results. And here we have lots of different years and file formats included. But if I just wanted to find mosaic data for Monroe County, I get that list here, and then if I wanted to limit it to ECW files, I can get those as well. And then you can clear those filters as needed. And if you sort by title, all of the data sets in ISDP start with a date, except for the standard ones and the topo maps, I believe. And so if you sort by title, you can get the oldest or most recent ones at the top of the list pretty easily. One of the questions I get a lot is, what if I don't know what quadrangle the data set that I need is in? And so we have an Esri app included in ISTP under address lookup, where you can put in a city or a specific address, and it'll tell you where it is. So if I'm looking for the CIB or the technology park where I currently am, East 10th Street in Bloomington, and then it'll show which quadrangle that belongs to, and it gives me the name and the ID number. And then you can find that data using the quad name or ID throughout ISDP. When you have submitted a request, like the ones I did a little bit earlier, you will see those under My Downloads, and they'll either say processing or completed, or something hasn't worked successfully, it'll say failed, please resubmit. Once you have a download available, you'll have a click to download link through the site. You'll also get an email that has the link to download it as well. We, of course, have a contact us page. You can contact us through our support form here or at uhgis@iu.edu. And before I wrap up the demo, I wanted to take a few minutes to show you a new feature that we're adding to the site. It's not live yet, but we'll be adding it within the next couple of weeks. And so we've added a clickable map search for the ISDP. So in the next couple of weeks, you'll see the homepage will look a little bit different if you go to ISDP. You'll see just that quick intro, but then you'll have the option to search ISDP by county or by quadrangle, and then you'll go to that search page. So if we want to search for Elkhart County, you just click here. It'll take you directly to the search results, which then you can filter by type or file format to make the returning results a little easier to browse through. Because depending on the data set you're looking for, the county, you can return, several dozen, if not, or hundreds of results. And then, of course, you can do the same for the quadrangle as well. Let's go back, sorry. And so if you're looking for Chesterton quad, mouse over it until you find the quad you want, return your results, and then you can filter those as well. All right. And just here, I'll put our closing slide up. And thank you very much for listening today. I want to take a quick moment to acknowledge the amazing team members that I work with that make ISDP possible. My manager, Santuna, contributed a lot to this process and to the initiative to maintain and keep developing ISDP. I have wonderful coworkers, Alan Walsh, Guangchen Ruin, who's left the team but did a lot of the infrastructure work, Jun Wang, who's taken over our infrastructure support, and my absolutely amazing undergraduate GIS intern, Jude Kincaid, who has helped a lot with maintaining and adding to ISDP's new features this year. It takes a lot of work to get ISDP up and running, but we're very excited to keep having it available for y'all and to keep adding features to the UI that we think will make it a better experience for folks to download data. Thank you.
Thank you, Katie. We'll take it over from here. Good afternoon. My name is Jinha Jung. I'm a faculty member of School of Civil and Construction Engineering here at Purdue University. And today I'm going to talk about geospatial data resources available at Purdue University. I'm going to have a very quick kind of history of how we started these services back in 2020. And I'm going to switch my screen back to demonstration and have some hands-on interaction. So Shaun already covered this Indiana statewide LiDAR and Imagery program. We have a first cycle completed in 2011 and 13. And at the time, Shaun, please correct me if I'm wrong. This is the numbers that I got from some some document, but overall budget was around $4.6 million and ended up generating about 11 terabyte of data. And we had another statewide LiDAR and auto imagery data collection happen. No, I think, please take me back. I think this 2016-20, this was in a LiDAR only, but then a QL2 data, which ended up having to be 6.6 million in overall budget and generating 13 terabyte of data, which is a lot of data. And right now we are in the middle of completing another statewide data collection. Shaun already mentioned there's some problem with the 2025, so everything will be delayed by year. But by end of 2028, we should have another statewide LiDAR and a 3-inch ortho image become available. Shaun, I don't know how much is the budget for this data collection. And I also, Shaun, I think you gave me some number. It's going to be a lot larger than 13 terabyte, which is from the previous one. Shaun, I think you want to comment on that?
Yeah, the total cost for imagery and elevation is coming in right at $10 million. So,
Okay.
but the numbers previously for other programs were correct as well.
Yeah.
So.
And estimated volume of data, I think there is one time you mentioned about this number was a pretty big number. I don't remember what it was. It's in
Yeah,
tens of terabyte.
I think it's estimating around 50 to 60 terabytes.
Yeah. So I came to Purdue in 2019 from Texas. And when I first came back to Texas, this is at the last ending cycle of 2016 and 2020 data collection. There are still some counties that need to be reflown because of flooding in the southern region, but the initial plan was to finish everything in 2019. So when I joined this Isaac Elevation Working Group, we've been talking about, hey, we have some of these data available, and how we're gonna share this in a data set. At the time, the way this was, working is that those vendors is gonna be, of course, there's gonna be QA/QC process. Once those QA/QC process is done, and all this data set will be stored in external hard drive, then they will be mailed to the central, at the office. In this case, GIO. Then this email comes out to everybody who is involved that, hey, who want to have a copy of this data. Then this external hard drive will be mailed to that first person. And as soon as that person is copying whatever the data that person needs, and the email will send out, and somebody will raise a hand. It'll be shipped to that location, and shipped to the location, and etc. So which worked fine. Because there is not so many people who need to have a copy of this massive volume of data, but it was quite a tedious process and at the time. So that's when after I joined Purdue, that hey, we are in the age of internet. We have a much better way of sharing this data. So I started working on this developing the Indiana LiDAR data portal the time, which is based on server available in a Purdue data center, and basically put all those data set on our Purdue server so that everyone can access very, very easily. And this is the website that we developed at the time. It's called lidar.digitalforestry.org, because this initial server purchase was supported by Institute of Digital Forestry at the time. And we just implemented these services. Here's a QR code. Here's a website URL at the bottom. And we started hosting this data set since 2020. So what I like to do is, and I like to go to the website here, open up the browser. This is an open to public. Anybody can just access it. Simply type in lidar.digitalforestry.org. Then you're going to see a data disclaimer. This is some information about, who is providing this data, some information about this 3D program, LiDAR data, metadata, and all the other information is available in data disclaimer window. Once you click OK, then it will zoom into this screen over here. And in order for you to find the data that you need, it is pretty straightforward. Just zoom into the area that you're interested in, click the county, then there is going to pop-up menu show up. Then there is a link says LiDAR data download. You just click the button, then you will zoom into that specific county that you just clicked, and you will see this tile boundary. This is the one that Shaun mentioned, and also Katie mentioned as well. But we also already embedded this information there. Let's say I like to download LiDAR data over this tile. And if you just click this, then remember we have a 2 statewide LiDAR data collection available, 11 and 13 and 16 and 20. And this link to download specific point cloud this service model, this terrain model, and ortho imagery, because we had a imagery and LiDAR data collection happen in 2011 and 13. And for the 16 and 19, we have a LiDAR point cloud ESM DTM normalized design model becomes available. So you can just click this specific file and download to your local machine. Then simply you can just use in any of the GIS software out there. One of the other features that we added also here is we are in Allen County here. We can also visualize this in a LiDAR data product without downloading it. So if you just turn on this in a DTM, you can actually see that this elevation model displayed over here. You can just zoom in to see detailed the information. You can also turn on normalize this height model, which is essentially in height above ground, so that you can see all the buildings and the trees over there. This is the data set for 11 and 13. We have the same thing for 17 and 20. We have also normalize this height model in a drive, then you can just easily visualize it. And if you like to download a specific tile, so again, just click this in a specific tile, then you can just download all this data. And the good thing about this one here is you can easily look at the changes in any of these DTM, very, very easily. So I'm hoping to see if there's anything I can find. I mean, I've never looked at this region before, but I can see there's some changes on over here. Any of the water stream changes over here. This can be done very, very easily without actually downloading the data. Same thing for this one here. If there is any new development, let me go to the Hamilton County, because I know that's the area that is changing very rapidly. So I'm just going here. I'm gonna turn on this normalize this height model, and let me go to some of the area that do I see. I think that this is a good example here. This neighborhood over here, it was not there in 2011 and 13, but you can see that there's all this new construction happening. This can be done, checked, very, very quickly. And if you like to download this LiDAR data for this specific region, then there's all the links available, over here. So we started this in 2020, and this is actually number of visit per month. We started in August in 2020. In the first month, we have about 100 visitors, and we've been having pretty consistent increase in number of visit in the first year, which we are very happy. And as these years going along, so I think this was the first year. I think this is almost year two. There is a consistent user growth, from there, and what we start to offer at that time is by around late 2021 and early 2022, this cloud optimized data format start to become a standard where you don't have to download the data. You can stream your geospatial data over the network. In a lot of cases, like Katie mentioned, that some of those quadrangle also can be in the order of tens of gigabytes. And you may have to spend a lot of time to download it, but that takes a lot of time. Plus, there might be some cases where you don't need the whole quadrangle. You just need only just small portion of the corner that need to be downloaded. So we start to support this on a cloud optimized GeoTIFF as one of the data format in this forestry, the LiDAR data portal. So what we did is we developed a QGIS plugin. So I'm gonna talk about the S3 data product access of those cloud optimized data format later. But we started with the QGIS because this is an open source where we can easily develop some new extension with some of the newer technology. So if you are a QGIS user, you can just quickly search for Indiana as a keyword. Then you will see two data product over here. We publish Indiana Ortho Imagery plugin and Indiana LiDAR, the plugin over there. Then once you install, you're going to see these two icon here, Indiana LiDAR and Indiana Ortho, becomes available. And if you need to access the DTM, for example, And you just need to pick a county. So let me pick Hamilton County over here. And this is the actual URL to the cloud optimized data. But you don't have to download it. You simply click Add to Map. Then you'll see that this actual digital train model for Hamilton County has been added automatically. And I can also add hillshade images for this one as well. And let me do a little bit of the visualization technique where I'm gonna change the symbology to be pseudo color. If I just do this, you're gonna start to see these images. But I see that. Let me just look at the histogram of this value. There's a very extremely low value, but there's very little. So meaningful minimum is going to be somewhere around 720. So I'm going to set this minimum to be 720 and click OK. Then you will see a lot better contrast over there. Then I can also do some, the rendering to be multiply so that I can see the, underlying, heat shaded images. But now we are actually seeing whole countywide digital train model. I just visualize in a couple of seconds. Once you zoom in, this is the part that video of this cloud optimized data performance comes in. You don't have to download it. They are just streaming this section of the area at the resolution that is needed so we can visualize it. And you can just further zoom in. You will see that this blue mark over here. This means that we are streaming the data, but we can access this whole county-wide digital train model, which was derived from the LiDAR data right away. I can also add normalized digital height model that I mentioned earlier. Let's do this. And this is the same as in a TIFF file in your local. I'm going to say that they're going to set on the fly. The transformation is happening there. Let me choose different color map. And I know this is in height above ground, so this should be around 0 to 85 feet. So if I just do this and simply zoom into a certain area, then you will start to see the exact same, layer that we saw from LiDAR, digital forestry portal that get be replicated into your GIS environment, very, very easily. We also can access all the data set, for, Indiana Ortho Imagery using this, Indiana Ortho, plugin as well. Let me go to the same Hamilton County. We have all the way, back to 2012 to 2024. I know that 2024 is 3-inch ortho. This ortho imagery is close to 1 terabyte. And let me just try to load this up. I know this is going to be slow, but this was pretty quick. We just loaded about 1 terabyte of the Indiana Hamilton County 3-inch ortho because we only streaming the low resolution tile. But if I just zoom into this small corner, then it is streaming this 3-inch ortho at the resolution that is needed to be displayed in this QGIS screen. So I think that this is a pretty big file. So they're going to do a lot of kind of clipping, not exactly clipping, but doing our data search. And there's some indexing over there. So it is happening there. But I think you got an idea. Just we have a 3-inch ortho becomes available right away, or you can start zooming further. Then they will be streaming even higher resolution data set becoming available. So I think that I was probably a little bit too ambitious to demonstrate the biggest file that is available in an archive. But just give you another example. So let me just go to Tippecanoe County. Example, the Purdue campus. I'm gonna do 2023, add this in a data set to QGIS. And I can just zoom into Purdue campus here. And you can see that this is pretty responsive. And this is actual, the uncompressed, GeoTIFF images where you can do For example, like Shaun mentioned, if you like to do near infrared band to be used for visualization, you can just simply force band this in a near infrared. Click OK, then you will see color infrared images will be being rendered automatically. We give a few seconds. They're streaming this in the data, and you see, I think that there's some network error, but you have an idea that now we have this color infrared images becomes available. This is from from the cloud. You don't have to download the data. So once we make this the cloud optimized data set become available from our data server, then our user base is even growing more. So remember, it started from 100 visits per month, and about a year and a half ago, I think most visit was the 2,000 visit per month, which is great. But we can see that the usage of this platform is increasing more and more. And since then, what we also start to offer here is, let me go back to this one. We developed a stack repository. Stack stands for Spatial Temporal Archive Catalog, and this is becoming a de facto standard when it comes to make your geospatial data available to the public. And we just established these stack services in our Purdue data center, and you can publish all the metadata about your geospatial data into this catalog where people can actually query the data that you need, and that they can just use the data right away. One good example is that I already demonstrated this in the ortho imagery, and the good thing about this is now you can do search and go to, for example, I'm searching for an item. I'm gonna filter by specific location. So let me go to Hamilton County again. Let's see if I can find this in an airport. Okay. Then I need Indiana ortho imagery collection to be used to search for the data that I need, and simply click submit. Then they will give you all the data that is available. So you have a countywide mosaic over there, but we also have all those individual tiles available. So if you just click this one here, it will show you that, hey, this is an actual coverage. And if you like to see this data set inside the browser directly, you just click this button, and it shows up inside this browser. And again, we are utilizing this cloud optimized technology where you can just zoom in and you can see this doing auto directly from over here as well. And we can also search for LiDAR. So for example, Indiana LiDAR point cloud. And if I just search, come back here, doing the same thing again. Let me see. Let me go to IU campus this time. Where is IU campus? I don't know. I'm assuming somewhere over here. Okay, yeah, I think this is where it is. So I'm gonna say I need the data over here, and I'm gonna say Indiana LiDAR point cloud data, and click submit. Then you will see there is one tile available. This is the actual coverage of the tile. If I just click this button over here, then you can see this point cloud becomes available. I think that there's some point that is noisy. And let me see, doing filter by, there's certain high value need to be filtered down, plus, and over here, then you can actually zoom in. And let me just increase the point density a little bit as well. And this data set becomes available without downloading any single data to your machine over there. And we also had a whole 3D point cloud data set that's also available as well. So coming back here, we have a nationwide coverage. Click search. Then I'm going to also search for an item, filter by an extent. Like I mentioned earlier, 3D is nationwide coverage. Then I can go anywhere I want. So let me go to Tulsa. I've never searched data set over here. But let's say I need a LiDAR data over this location. And the data set that I need is in a 3DAP. Click submit, then they will find that, hey, there is a, the 3DAP data set acquired in 2016 to 19. Simply click this, and there is an opening, this in a cloud optimized viewer. Then you can actually see this data set becoming available, right away. Let me just zoom in. This is also, cloud optimized. So you can see this in a point cloud, right away. And we also have, NAIP imagery, nationwide coverage as well. So if you come back here, where is the NAIP? NAIP imagery coverage as well. So you can just do the same thing. I can search upon item. Let me go some external location. Let's go to Maine. I'm going to just go certain. I even don't know where is, this town. I'm going to zoom in. And the collection that I'm interested in is in NAIP imagery. And click submit. Then these are all the NAIP imagery available from the cloud. Simply click this link here. And this is the actual cog tile. If you want to load this into QGIS, I'm going to copy this URL. Coming back here, I'm going to create a new project. Save it. Add the raster layer, but this is going to be a web protocol. Simply paste the link that I copied from the stack, add it, and give me a second. And they just added this in a imagery, available to you. If I just turn on this in a Google Hybrid Map, and you can see this is the NAIP imagery that I got this in a Google base map layer. And this is the beauty of this in a stack platform where you can discover data set you want, and you can stream this in the data set that is all in a cloud optimized data format to use it and visualize it and etc. So we implemented this beautiful features to stream this data set. Since then, the number of users is even increasing. So I just showing the trend from 22 September of October of this year right now. Remember we started from 100 per month. I thought that 2,000 was a lot, which was the maximum before, but recently number of visits is increasing dramatically because of these stack services and also all those cloud optimized data format as well. And this is a very interesting statistics, but if you also look at amount of volume that we serve out of this system, you can see that there are some month where we've been hosting almost 30 terabyte a month. But remember, last 3 months, there is a significant increase in number of visits, but actual data volume hosted is quite less. This is a very, very clear indication that there's more people using these services, but they are not downloading this data. They are taking advantage of this cloud optimized technology so that they are just only streaming the data set that is needed to use for their operation. So I think with this, I'm going to stop my presentation, and I believe, Shaun, we reserved about 10 minutes for Q&A.
Yes, we did. Thank you, Jinha and Katie. Really appreciate seeing your the platforms that you helped support. And so at this point, you're welcome to put comments in the chat, or if you'd like to take yourself off mute, I believe you have that ability, and we can field some questions.
Oh, there's a question from Andrew. Is the breakdown of how much is on-campus IU, Indiana, outside Indiana? Let me see. I mean, this can be dangerous to show to the public, but we have actually some the analyzer I've been working on, and I don't think this reverse IPU is working perfectly. This is the statistics for what is it? This is an October month right now. So there is about, this is a distribution. So unresolved unknown is 44%. .NET is 26, commercial is an 18, education is only 11%. So anything that ends with edu. So, the educational use is only 11%, the rest of, the use is, almost 90% of use is, outside of, education. So there is, quite good use in outside of education institution who is taking advantage of these services. Oh, I think Gabri's says that how to find the data from Stack. So, one thing that let me just, Shaun, can I keep answering question from the chat?
Yes. Yep.
Okay. So, from the Stack, or is my mouse here? Simply go to stack.d2s.org. This data to science is another open source ecosystem that my research group has been working on. But coming here, you can click search. You can search for collection, or you can search for an item. So I usually go for an item here, and you can actually specify in a specific time window from when to when that you like to find the data, or you can filter by special extent. Then you can just zoom in to an area where you're looking for data. For example, let me go to the Logan Sport area. Let's say this is the area that I'm interested in a collection. I'm going to set it Indiana also imagery and type enter, then simply click submit. Then this will give you all the, the orthomosaic imagery available for this region from this in a catalog. And I believe that Shaun, I'll be working with Shaun so that all those, ortho imagery tiles will be also added to this stack as well. So you can actually discover those individual tiles as well. But let's say this is the one that you need, 2011. You can directly click this link so that you can see this ortho imagery, from this in a browser, right away. Or if you like to load this into your QGIS, then click here and copy this URL and go back to your QGIS and gonna start a new project, add a raster, click, this in a protocol to be in a HTTP, simply paste this link, click add, and it becomes available in your QGIS right away. And you can just zoom in, then you are streaming this ortho, right away. And if you're doing any geoprocessing directly here, you'll end up downloading whole county mosaic, which is going to tens of gigabyte. But if you need to use in a very small section corner over here, this is your area of interest. You can use a GIS software to clip only this portion to your local computer. Then they can run just geoprocessing. Then it's going to be a lot faster, to the processing on your local end. And I'm not sure whether they can open up their mic and ask question. I
Should
think
be
they
able
can.
to.
Yeah.
As far as the recording, we will have it available on our website, and I'll also be sending out a follow-up email with the link to it once we get it posted. Looks like we've got all the questions answered.
No,
Or do we
Andrew
still
is
have?
asking whether
Oh,
presentation is going to be available.
Yes. Yep. So we'll have the recording available, and then also save out the presentations. I'll just need to get the Katie's and Jinha's and combine it with mine, and then we can save out a PDF format. So. Want to avoid the PowerPoint.
I do have some. I use some,
yeah,
so I can share.
Yeah. But I am excited to have this opportunity to demonstrate, to kind of pull all these resources together, because I think it's wonderful that we have distinct ways of getting information of Indiana's geospatial data. And Indiana Spatial Data has been working on that archival. And I remember back in when I worked at Wayne County, that was I contributed to the Indiana Spatial Data portal, and then knowing that information was going to be there in perpetuity was a wonderful feeling. And with Jinha and his efforts in optimizing and also developing additional LiDAR products such as the DTM and normalized height differencing. So, all right. Any other questions? Well, with that, I think we can.
I think there is one more question.
One more
in the chat.
Okay.
I don't know how to answer that question because I'm not a Civil 3D user.
Yeah, we had we had a presentation on how to use our imagery services in Civil 3D. So we have that recording, but to give you the cliff notes is yes. There's an Esri plugin, which is what we found to be the best way to bring it in, and through that you have access to visualizing the imagery and elevation data. If you need to create contours and other products from the digital elevation model, you would then need to go and download the individual tile to be able to produce contours or to analyze the elevation. But to visualize the imagery services and the DEM are right there at your fingertips using those REST services, and those are in my resource page on the last slide of my presentation. So. Yep, good question. Glad to see that one come in. So we're always been pushing to try and get folks and users to use those imagery services. Those have been out there, and I think oftentimes overlooked. Users are intuitively think they need to download the data, and what we're seeing is with this cloud optimization, users can, especially with the stack that Jinha presented, users can view the products just by streaming. So. All right. Well, every time I say we're done with questions, another one comes in. All right. Yep. Yeah. So we'll have the recording available, and I'll send out a follow-up email with a link to that. All right. Well, it's 12:30 or 2:30, so let's call it a day. Thanks everyone for your time. Really appreciate your interest in Indiana's programs and access. So you're welcome to contact me if you have any questions, or Katie and Jinha directly. So thanks again. Hope you have a wonderful afternoon, and we'll see you the next time. All right.
Thank you, everyone.